So, can anybody tell me what an inequality is?
Me! Pick me!
Okay, I pick you.
An inequality is when my brother gets the last brownie. That is an inequality.
I guess that would be an inequality. But I was actually thinking of something more like this. X is greater than 3, not equal to 3. And then we would graph it. So if we're not including 3, we put an open circle and we shade to the right because it's everything greater than 3. Sometimes it's not that easy though. Can you try this one? Pause your video. Are you ready to see how you did? All right, so first you should distribute your -3 and your 6. Then move your ends to one side. Just pretend like the inequality symbol is an equal sign until the end. It just goes along for the ride. Okay, so then we get 3n minus 12 is less than 6. We add the 12. We get in there, we divide by 3, and we get n is less than or equal to 6. And then we can graph. Okay, and if it's less than or equal to or greater than or equal to, that's when you have a closed circle. Okay, and we're shading to the left. And one little hint, if you put a little line inside of your inequality sign, it makes an arrow pointing the direction you're shading, so to the left. One rule that you have to remember is that if you multiply or divide by a negative, you have to flip the symbol. So here we're dividing by -2, so we get n and -2, but we have to flip the symbol. So n is greater than -2.
Hi guys, can you tell me what an inequality is?
Yeah, I'll tell you what an inequality is. I can do this to his hair, and ain't nothing happening to it. But as soon as you touch my hair, it goes nuts. That's an inequality. Word.
This one is kind of a challenge for a couple of reasons. Pause the video and see if you can figure it out. Let's see how you did. Now the first tricky part is distributing a negative, so make sure you multiply that -3 through both of those. Then we have to attempt to get all the r's on one side. So we're going to add 6r to both sides, but then the r's go away and we get 12 is greater than or equal to 10. And that's a true statement. So if we get a true statement and there are no variables, then your answer is all real numbers. That means any real number that you plug in for that letter R makes this statement true. But what if you have something like this? And we get something that's false. 3 is not greater than 7. If it's false, then that's no solution. So that means that there is no number that you can plug in for x to make this true.
Can you tell me something that is an inequality?
I would be glad to. Matter of fact, it would be nice if someone would point out to my wife that it is unfair, it's an inequality, that she constantly hogs the remote for the television. So that means that I watch what she watches.
Next we have compound inequalities, which are the and or sandwich problems and the or problems. Here's an example of a sandwich problem. Can you solve it? All right, let's see. So we have to do the same thing to each part of this inequality. So we need to get x by itself in the middle. So we will add 1 to each piece. And now we're going to divide by 3 for each piece. And so we get 2 is less than x, which is less than or equal to 6. Okay, and then we need to graph it. So Since x ends up being greater than 2 and less than or equal to 6, we have an open circle at 2 and a closed circle at 6. So everything in that graph will make this original statement true. And don't forget your interval notation. If you're including the number, then you use a bracket. If you're not including the number, you use parentheses. So we put parentheses before the 2 because we're not including the 2, but we are including the 6, so we use a bracket around the 6. Now here is an OR problem. Do you think you can get this one? So you're actually going to solve both of these. Okay, so for both of them, we'll start with adding 3 to both sides. Then we divide by 4, and we get r is greater than 4 or r is less than or equal to -2. So that means any number that's either greater than 4 or less than or equal to -2 will make this thing true. Okay, and then we graph it, and it looks like these little paddles or oars when you kayak, right? For interval notation on this one, I think it's easier to look at the graph. Okay, here it's everything less than or including -2. So you go to the left, so you start at -infinity because it goes all the way negative. Okay, you always put parentheses around infinity. And then you put the -2 with the bracket because we're including the -2. And then we put or, and we are not including the 4, so we put parentheses, and we're going all the way greater than 4, so we go all the way, it never ends, so to infinity, and then parentheses. Any other inequality examples? Oh, the wizard must have an example. Whoa, that just appeared out of nowhere. Okay, so we have a couple of absolute value inequalities. What a great introduction. Thanks, wizard. The wizard jumped ahead of us. We haven't even talked about absolute value. So we will take a step back. If the absolute value of x is 5, then x has to either be 5 or -5, right? Since the absolute value is the positive of whatever is inside the symbols. So we could write our answer as x is equal to positive and -5. How about this? Is there anything we could plug inside of absolute value symbols to get a negative number? Absolutely not. So that would be no solution. And now let's solve an equation with absolute value. Okay, do you think you could do that? If you can, pause. All right, so we're going to just kind of think of those as parentheses right now. We would never distribute into absolute value symbols, but think of it as kind of like dividers. Okay, so we need to get the absolute value stuff by itself. So we're going to subtract 1 from both sides. And we have this. That means the absolute value of 2x minus 3 is going to equal 7. So that means the stuff inside can either equal 7 or -7. So what we do is we set up 2 equations and we solve both of them. 2x minus 3 equals 7 and 2x minus 3 equals -7, since the part inside of the absolute value symbols could equal 7 or -7. Then we go ahead and solve that. And we get x equals 5 and x equals -2.
Can you think of what an inequality might be?
I think an inequality is something that's kind of not fair. Like an example could be, I don't think it's very fair that as I get older, my hairline decreases, yet my waistline increases.
If it's a less than problem, it becomes a sandwich. So we write it as it is, x plus 2 is less than 3 without the absolute value symbols. And we write the same symbol with the negative on the other side. And then we just solve it like a sandwich problem. Okay, and we end up with negative 5 is less than x, which is less than 1. And then we graph it. Easy as that. If it's a greater than or more than problem with absolute value, it becomes an or problem. Okay, so we're gonna write it as it is, and then we're gonna say or, and we're gonna flip the symbol and change the sign. Okay, and then we solve it just like an or problem. And we end up with x is greater than 2 or x is less than negative 3. And again, we graph. And there's our answer in interval notation.
Inequalities? Yeah. I can think of one. I grew up around a major inequality. Makes me guilty just thinking about it, actually. Just knowing that whenever I wanted, I could eat my favorite cereal, but knowing that there was others out there that couldn't. Knowing that if my favorite rabbit friends wanted a bowl of this cereal, I had to say to them, "Silly rabbit, tricks are for kids." Makes me sick just thinking about it.